essentially is the first composite. It's an organic material, naturally composite of cellulose fibers, embedded in a matrix of lignin, which acts like a resin. Because it's stronger in the direction of the fibers, it's anisotropic as opposed to metals. Okay, let's go to the next decade, the 1910 to 1920. That's when metals started to come more into play for aircraft. The first all-metal airplane was produced in 1915 by Junkers. It was steel tube, and they used corrugated sheet iron for the skins. The corrugation gave them stiffness and allowed them to reduce the weight because they could get stiffness through the geometry of the corrugation versus just a flat sheet. You'll notice during this time period that the speed now, we're not going 6 miles an hour. By the end of this decade, we're up to around 190 miles an hour. So in a very short period of time, aircraft went from just barely flying to going almost 200 miles an hour, in large part because of the introduction of more sophisticated materials that allowed that speed to increase. Plywood was also optimized, particularly on the LFG Roland C2. That was the first use of a semi-structural skin. So recall the Wright brothers were using fabric. That was just basically like a sail on a sailboat, just to allow airflow to go in a certain direction. The introduction of plywood actually allowed those skins now to start to carry some load, so your structure could become more efficient. Moving to the 20s, Ford introduced a stress skin or semi-monocoque design that really depended now not just on the internal rib structure, but now the skins were an active part of aircraft design, referred to as semi-monocoque. Again, they used corrugated steel. Wooden wire was still popular then. This is when the aviation industry was really starting to take off. The Spirit of St. Louis, when Lindbergh was the first person to traverse the Atlantic. Also, Amelia Earhart was becoming active in setting various records. And you'll see now we're going from just under 200 miles an hour. So the second decade, we've now gone up to almost 350 miles an hour by the end of the decade. Okay, the 30s. This is when we're starting to see more introduction of aluminum. Aluminum had a problem with corrosion, and in the 1930s, a product called Duraluminum was introduced, which included a copper alloying element to make it more corrosion resistant. I'm sorry, increased the strength, but it still had corrosion resistance. The development to address corrosion was through a process called ALCAD, where the Navy funded a process to essentially clad the exterior surface of the aluminum to make it corrosion resistant. So you got increased strength with the copper, but it corroded. They then developed a corrosion resistant coating, which we refer to as ALCLAD. At the same time, chromic and sulfuric anodizing processes, that's an electrolytic oxidation of the surface of the aluminum to make it corrosion resistant. That was also introduced. Spot welding was introduced, and stainless steel started to become prominent. This Budd company produced stainless steel for rail cars, and because of the Great Depression, their business was being affected, and so they were looking for other uses for stainless steel. And one of the things they pursued was the development of stainless steel on aircraft. And so this Budd BB-1 Pioneer aircraft was the first all stainless steel aircraft produced. Speed records now, from now going up from 400 to 470, so continuing to go faster, continuing to fly higher, which is leading to cost and weight trade-offs. In order to go faster and higher, you need to be lighter weight. So materials, again, a big role in that. The other aspect was plexiglass was introduced in 1936. Plexiglass was used for the canopies, and it was one of the technologies that enabled the cockpits to be pressurized. Because you could now pressurize the cockpit, you could now go to higher altitudes with the aircraft. Okay, well, where was rotorcraft in all this? Well, Igor Sikorsky came around, and in 1939, he developed the first production helicopter, known as the BS-300. And again, it was predominantly wood, spruce, and canvas. Cross-section of that blade shows you that it included some plywood, a steel tube, some wood ribs. It had poor balance and tracking because the wood would absorb moisture. It had a fairly low forward speed, and the airfoil shape retention was challenging because all of those materials weren't all that robust to the environment. Okay, moving to the 40s. This was a huge step change in the aircraft industry, predominantly because of the onset of World War II. Fiberglass polyester components were introduced. Performance of aircraft needed to improve because of in large part because of the war. The performance of the aircraft drove engines being more powerful and thus hotter, so that led to the development of superalloys to take those temperatures. But another unique aspect was FDR, Franklin Roosevelt, challenged the industry to go from producing 2,000 aircraft per year to making 4,000 aircraft per month. That was a huge change, a huge challenge for the industry. And the only way they could do that was by suspending the auto industry and converting it to aircraft. And by virtue of doing that, they incorporated several of the automotive manufacturing techniques into the production of aircraft to A, get rates up, and B, get costs down. It took 55,000 hours in 1941 to produce a B-17, but by 1944, it only took 19,000 hours to produce a B-25. So a huge change in manufacturing costs precipitated by looking at how you manufacture your product differently. Sikorsky also went into production at that time with its R-4 helicopter, which was the first production helicopter program. Speeds at the end of the 40s are up to over 650 miles an hour, 670 miles an hour. Okay, in the 1950s, titanium comes on the scene. Titanium Metals Corporation of America was a joint venture between National Lead Company and Allegheny Ludlam Steel. Titanium was 40% lighter than steel, corrosion resistant, acid resistant, high strength, high temperature capability, basically a near miracle material. Problem is it was fairly resource limited. Titanium ore wasn't easily